Now, friends, you are all welcome. Now we are going with the most important subject is the relationships of the variables. If you look to this, that we are searching a pattern actually. In fact, mathematics is a subject of pattern searching. Lot of observation is generated by the physicist, chemist, biologist, and many other branches of science. But the mathematician tries to find out a kind of a pattern out of the relationships of different variables. And this is one of the examples how the pattern searching is taking place. Next. Now, there are relationships of variable. If the economic growth increases, stock market tends to increase as well. This is a social phenomena all we have observed. Like that environment, BOD increases, COD tends to increase as well because BOD is a subset of COD. Environment, BOD increases, DO falls. BOD is a biochemical oxygen demand, is the demand of the oxygen by the bacteria to stabilize the decomposable organic compound. In the process, the organic carbon tends towards carbon dioxide. So they consume the dissolved oxygen in the water system, aquatic system. And such, therefore, when the BOD increases, DO definitely tends to fall. Next. We see there are two variables, how they are tends to find out a pattern. In the first is the variable A and variable C. They are variable A is increasing, variable C is also increasing. In the second is that variable B is increasing, where variables D is decreasing. That means one is a positive relationship and one is the inversely relationship. Now the question is that, can we measure these relationships? That was the question. Next. There are two parameters which help us to measure the association of two sets of variables. One is the covariance, another is the correlation. In our last lectures, we have defined the variance x minus x bar to the power square n minus 1. The sum of square divided by n minus 1. If it is a small samples, it is n minus 1. It's a very big, it is n. So this is a variance. Covariance is that simultaneously two are operating. That means operating in x-axis, the variables, and operation in y-axis variables. So we have a sum of variables 1 into sum of variables 2 divided by n minus 1. So that is the covariance. Now measurement association between two variables, another parameter is the correlation. It is covariance of x and y divided by variance of x and variance of y within the root. So here you see in the first in covariance, we have a milligram per liter. Say suppose x-axis is BOD, y-axis is COD. So it is a milligram square. But in case of correlation, the number become dimensionless. This is a difference between covariance and correlation. In covariance, there is a dimension. correlation is dimensionless. Next. Both covariance and correlation indicates how the variables are related. The positive value of covariance or correlation means that the variables are positively indicates, are positively related. If one variable increases, the other increases. The variables are indicate that they are inversely related, and correlation, as I told earlier, that is a dimensionless number. It's a ratio. A covariance as unit, and the correlation indicates the degree of relationships. If it is a more 0.5, 0.6, like that, they are giving the degree of relationships. Next. Now, look to the picture. We'll find the first picture is a cluster of the points on x and y axis. They are not related. Zero correlation, it is. But in the second, we got a pattern that with the increase of x-axis, y-axis, variables at the y-axis is decreases. This is a negative correlation, whereas here, with the increase of the variables at x-axis, the y-axis also variables are increases. This is a positive correlation. So zero correlation, negative correlation, and positive correlation. So this pattern we are always finding. Maybe it is not a linear like this. Maybe it is a non-linear also. But we can make it. We can find it the pattern when we will go in the subsequent discussion of this lecture. Next. Now, how to calculate covariance and correlation. So, first you see the result. X is 1, 3, 4, 6, 8, 9, 11, 14. And consequence position of the y is 1, 2, 4, 4, 5, 7, 8, 9. So first you will place these things in x and y, two variables. Find out the sum of the x and sum of the y, because we have to go for a and the mean x bar is 7 and y bar is 5. Now we have to find out sum of square. So sum of square is that x, small x, x minus x. So our mean is 7, x. So 1 minus 7 is minus 6, and 1 minus 5, 4. Now you square it, 36 and 24, and also 16. So 36 is x square, xy. This xy is 84 and y is 56. So covariance of x and y is xy divided by n, that is 10.5. Next. Next. So correlation is sigma xy, sum of x and y product, divided sum of square, the 84, and it is coming 0.97, and covariance is coming 10.5. So this is the formula for doing this job. It's a very simple thing, and you will do this thing very nicely, I am sure. Next. Now, if it is so, if there is a correlation, strong correlation is there, can it be forecasted? If we want to forecast, we have to find an equation. That equation will predict if we have a series of data and you plot the data and make a correlation. If the correlation is more than 0.5, you will find some sort of pattern is there. It may be linear or it may be non-linear. Let us discuss this point very coolly. Next. Most simplified relationship between two variables x and y are y equal to function of x. This means that x influences variable of y. F symbolize the functions and functions indicates this type of relation, linear or non-linear, slope and intercept, that has to be found out. Simplest linear relations is y equal to mx plus c. It is the straight line. So first thing is that two variables are related. That means y equal to function of the x. Function indicate that the variable x influences the variables y. Now, simplest linear relation is y equal to mx plus c, where m is the slope and c is the intercept. This is very, very known phenomena to you. Next. So third equation is y equal to m 1 by x plus c. It is also a linear equation. Here the data x-axis is 1 by x and they are giving this thing. Now y equal to a to the power e to the power a into e to the power mx. It is a non-linear. And y equal to a into x to the power em is a non-linear. Now what is happening if there is a non-linear? Let us see the equation number 4. If we take log, so log y equal to log a plus mx. Mx means log e is equal to 1 and log a is coming plus is coming because there is a multiplication there. Same thing. So non-linear equation you are transformed to the linear equation by the help of the logarithm. This is happening. So y equal to a x e to the power m. So if log y is there, so log a plus m log x is equal to 7. That is your, in the case, because in the case of fifth nonlinear equation, and is be transformed to logarithm scale at the equation number 7. So nonlinear equation is there. You can transfer it to logarithm and can go. The biggest nonlinear equation is that c equal to c0 e to the power minus kt. That is the BOD biodegradation rate. If you log it, so log c equal to c0, log c equal to log c0 minus kt, where k is the slope and with time actually. So y equal to minus mx plus c. But with time, BOD will be degraded. That was the given. Because it is exponential equation, it will never reach to the nonlinear, it will never reach to the x-axis. But it is very close to asymptotic pattern, it will go. That is the way the nonlinear equation works. But if you log it, you can get the slope and you can predict when what day BOD will be the minimum. Next. Now, how you will measure it? You see that equation there. Here is a y and x. And we got a straight line. Line of best fit is the line that passes through a set of points in such a fashion that the sum of distance of each point from the line is minimum. That means the straight line and the points, it will be mid area where all the points are very close to the straight line. This is the straight line. Now, how we will know it is the minimum straight line? Let us do some kind of a small arithmetic over it. Next. Now, D, sum of the distance. Distance means that point D1, D2, D3 from the line. So sum of the distance, we are making square because there is a negative of the slope is there. Position of the D2 is the negative of the slope. So negative and positive has to be all positive. So that's why we are squaring it. That is the tricks of the mathematics. So D equal to D1 square, D2 square, D3 square, D4 square and D5 square equal to minimum. So D is equal to sigma Di square. I equal to 1, 2, 3, 4, 5, 6. This has to be, which is the minimum. How we will do it? Let us go with an example. Next. Now, a distance is measured 4 times. And we get the results 72, 69, 70 and 73 units. What is the best estimate of the correct measurement? That was the question. Which is very close? Which is very close? So let us do it. Next. Let us denote the true value as x. That means deviation from x is the error. So x minus 72, x minus 67, x minus 70, x minus 73. And the sum of square, what is sum of square of error? X minus 72 square plus x minus 69 square plus x minus 70 square plus x minus 73 square. In order to minimize the s, that is sum of square of the error, the equivalent form is coming like 4 into x minus 71 whole square plus 10. The minimum value s is 10 when x equal to 71, as the which is the average value of the 72, 69, 70 and 73. You may not be happy. I also feel how the equation comes 4 into x minus 71 whole square plus 10. It is true that physically you understand if x is 71, then minimum distance is 10. So that was the question. Minimum value is 10 when x equal to 71. That is mean is 71. True value is 71. But how this equation came? Next. It's a matter of little bit. Next. Now it is the sum of square of errors. That was the thing we have to first understood. So x minus 72 square plus x minus 69 square plus x minus 70 square plus x minus 73 square. This was the thing we got. So it is a minus b whole square. So x square minus 2x into 72 plus 72 square. So x minus 69, x square minus 2ab, 2x into 69, 69 square. Same with the 70 and 73. Now we got a big value. That is 4x square minus 568x plus 20174. Now, if you take 4 common, we will find 4 common x square minus 142x 5043.5. Now we are going close. We have to go for a minus b whole square equation. If we take 71, we will find 5041. Now it a tricks is giving. We are now going a minus b. So it is 71 square equal to 5041. You can calculate it. Now 2.5 is extra. 4 into 2.5 is equal to plus 10. And that is why the equation. I hope you understand. You do the arithmetic calculations with the algebraic equation a minus b whole square and addition and subtraction. You come equation 4 into within bracket x square minus 442 plus 5443.5. Now 71 into 2 is the 142. So 71 square will be the, if I want to go a minus b whole square, and 71 square is coming at 5041. Now 5043.5 minus 5041 is 2.5. 4 into 2.5, this 10 is extra, so we add plus 10. So we got the equation 4 equal to x minus 71 square plus 10. The main is 71, then it is 10 is the minimum. That is why sum of square dot has to be estimated. I hope you understand it. Next. Now, line of best fit illustration with examples. Now we are going to draw the equation. First, we understand what is the meaning of sum of square. This is the most important in analysis of variance. Already you have observed that how sum of square is playing the most important game. In statistics, sum of square is playing a very, very important game. That the meaning of the sum of square I have explained to you in my earlier slide. Now I want to construct a best fit lines. Let us go. Next. The methods of least square calculates the line of best fit by minimizing the sum of squares of the vertical distance points to the line. Vertical distance points means line is there, it's moving upward or downward, and the vertical distance, the position of the points, and that is that their vertical distance to the line is called is to be minimized, and that is the by minimizing the sum of square. So I have already explained to you what is. Now this is a value x and y. X1 is 2, x2 is 4, x3 is 6, x4 8, x5 10, x6 12, x7 14. And we are getting y1 is equal to y1 4, yn 4, y2 y3 4, y4 5, y5 5, y6 7, and y7 we are asking a question. If it is a best fit, we put the value of x7, we should get the y7. Because we have a equation y equal to mx plus c. So we know the m, we know the c. If we value the 14, we will get the y. That's the best fit. Next. Now, due to random errors in the measurement, the ordered point x1 and y1 do not lie on a straight line. So assume the values can be approximated by the linear function y1 equal to ax plus b. This is the deviation di, yi1 minus yi. So yi1 equal to axi plus b. Because y1 equal to ax plus b already we have assumed. So x plus b minus yi. I equal to 126. So that is the things which we have given to our data. The x1, x is values, y values we have given in the data. Now we got the minimum deviation di. We got the di equal to axi plus b minus yi. Very nice. There is no problem in it. You understand it. Next. Now sum of square we have to go. D1 square, D2 square, D3 square, D4 square, D5 square, D6 square. So now D1 square, 2a plus b minus 2 square. Because our original data x is equal to 2. Right. Original data x is equal to 2. Whereas D2 4a plus 4b, this data also 2. I am telling you because I cannot go here and there, back and forth. I cannot do here now. It was the difficulty with this type of training. So I have written somewhere. So I want to discuss with you this point very clearly. So I have already told you D1 square is equal to, so now D1 x1 is 2. So 2a plus b, because ax1 plus b minus I. x1 is 2, so 2a plus b minus 2. 2 is the y value. In the case of second point, 4 and 4. So 4a plus b minus 4 square. In third point, x3 is 6 and b is equal to 4. So 2a, so 3 to 6 plus b minus 4. So accordingly, the equation is coming. 364a square minus 84ab plus 6b square minus 436a minus 54b plus 183. I am leaving this slide to you. You can understand it. You should say d1 x is 2, y is 2. 2a plus b. So 2 into 2, 4. Right? 2a. 2a means ax plus b minus y. So a is a 2 and b is 2. In case of x2, 2a, 2x is equal to 4. D2 is a 4. So 2a, 4a plus b minus 4. So plus 6a, 6 xb is a x3 is 6, y is equal to 4, so 6a. So that is the way the equation comes like this. Now, if you differentiate the whole things, it is a simple thing. Is I am explaining you how differentiation comes. This equation above 364 plus a square, when you are going sum of square with the a, so 2 into 364 plus a, only a will be there, no b will be touched, only a is working here. Now as per the differentiation, derivatives is that if a square is there, so it will come to a and square will come to multiply with the 364. And here 84ab. So now a is 0. A x to the power 0 means 0. 1. So 84b plus 6b square. Nothing is there because a is not there. So not in the 436a. Here again 1 minus a 1. So a to the power 0 is 1 minus 436. 54b and 183 is not counting because we are doing differential equation. We are doing the derivatives, partial derivatives with respect to a. It is called the partial because we are doing with the a only. So the equation coming 182a plus 21b equal to 190. So this is the equation comes. Next. Same thing, if we go by B, you will gain 14A plus 2B equal to 9. So now 1 and 2, this equation if we solve, A is coming 0.41, B is coming 1.6. So we got the intercept, y equal to mx plus c, y equal to ax, is A is 0.41 and intercept is coming 1.6. That's the way we have to find out. So that is the way the mathematically this slopes and the intercept is coming. It's very simple. Those who have a little idea of the calculus, they can understand the whole things. If you do not calculus, you say derivatives, that means dy by dx. dy by dx is a small part of the slopes. It's called dy by dx. dy by dx, x2 minus x1 divided by y2 minus y1. This is the thing. Or sorry, y2 minus y1 divided by x2 minus x1. There is the derivative. Smaller the derivatives is the d has been written. Now here partial is doing, but first we do by a, then we do by b. And this is the way the equation comes. Solving 1 and 2, 0.41 and 1.6. Next. Now we have to go for a things. What is the formula of the m term? Sigma xy minus sigma x into sigma y by n, and sigma x square minus sigma x square by n. So first we have to calculate and slope interest incorporate the y. Then I will go for later. And the intercept equal to sigma y bar minus mx bar. So first you have to calculate the mean of x value and the mean of y value. Compute the sum of square of the x values. Because sigma x square whole square is coming and sigma x square, the sum of square, x square is coming. So compute the sum of each x values multiply its corresponding y value. That is xy. That you have seen in the case of the covariance and correlation. So calculate the slope of the line using the formula is this. Next. Now better to show you. This is the equation x 8, 2, 11, 6, 5, 4, 12, 9, 6, 1. Y equal to 3, 10, 3, 6, 8, 12, 1, 4, 9, 14. This is the equation. So plot the points. If you plot the points, 1 is the x-axis 1 and 14 is the y-axis. So that is there. 6 and 9. It is coming 6 and 9. Here is a 6 and 9 is coming. 6 is the x-axis and 9 is the y-axis. So all the points, if you plot like this, the things are coming like this. That is means there is some trend. We have to follow the best fit out of it. Next. So what do we do? So first sigma x, sigma y, then x and y. That means x value and corresponding y value 24. And we have to find out x square, sum of square. That is 528. Now you put it. Sigma x and sigma y, 64 and 70. So we put it. Divide by n. 10 values are there. So have 10. And xy is a 317. So 317 minus 64 into 70 by 10. Now x square is 528 minus 64 square by 10. So you get a little bit up. It is coming m equal to 1.1. So this is the value. This is the way you have to find out the slope. Next. Now sigma x bar is equal to 6.1. Sigma y bar is equal to 7. So what is B? B is y bar 7 minus 1.1 m into 6.4. It is 7.70 minus 7.70, 14 joule. So equation is y equal to minus 1.1x plus 14. If you see back, so we go back. So we go to back, please. This is the equation you find. If the x is increases, y is decreasing. That is the equation actually. It is coming down. So that is why the slope is coming minus 1.1 and the intercept is very high. Intercept is coming 40 actually. Chalo, next. Chalo, next. This is the equation is coming. So now you can do the m and you can do the c, that is the intercept, and the equation has come like this. Please go back. Go back. Go back. Go back. Actually, go back. Go back. Go. Back. Now, what we are trying to tell? We are trying to tell the sum of square of errors. We have to calculate the sum of square of error. And from the next forward, next. So here we back. Next. Here we are doing the sum of square of errors. I have explained you how to get the sum of square of errors. That means distance from the mean, the real value, which you observed value, minus x minus observed value. X is the true value. And you are finding out the distance, that is the sum of square of errors. That means what is the deviation? Sum of the deviations we are calculating here. Next. Then we are going with the best fit. We go x1, we get the measurement of two quantities x and y. Say do and BOD. We are doing x1 is 2, y1 is 2, 4, 4, 6, 4, 8, 5, 10, 5, 12, 7, 14. So corresponding value, that is the xy. Right, next. So we found y equal to ax plus b. So what is the deviation of this? yi1 minus yi. yi1, yi is equal to ax plus b. So ax is I plus b. Just replaced yi1 by ax plus b. And we got this equation, the deviation. Next, we try to minimize deviation. D1, the x value is ax, x value is 2. So 2b to minus 2. Then D2 is a 4. 4, 1a plus b minus 4. So like that, we are doing this total deviation. We are calculating. We got an equation like this. We try to find out a and b by derivatives, partial derivative with respect to a. So we got an equation like this, 182a. And I have explained you how to do it. Next, with the b, we got the equation. So 1 and 2. Now you have solving the simultaneous equation. We got the value of a and b. And that's where slope and this intercept has to be calculated. This is the mathematical presentation of the best fit. Next, when you do the statistics, you say xy, that is corresponding value, and sigma x and sigma y, total sigma x and this divided by n, sum of square of x and total sigma x whole square divided by n, that is the value of the n. Next, when we got these things, we got equation y y x is increasing, y is decreasing. That is y equal to minus mx plus c. That equation should come, and we calculate it. Next, we calculate with the equation formula we are given to you. It is coming in, if value is 1.1, and next b value is equal to 40. So this is the thing. So intercept 14 this. So minus 1.1x plus 40. One thing I'm telling you, when a positive correlation, the intercept value will be very small. Whereas a negative correlation, intercept value will be very high, because it is coming top of the y to down of the x. So this is the intercept value is very high. Next. So this is the equation is coming. You will find that cursor to layer, you bring the cursor here, cursor come to here. See, it is a very highest value, it is coming down to lower value, it is 0. So the intercept is very high here. And it is a negative because minus 1.1x is there, m is the negative. So you come to the equation y equal to minus 1.1x. Minus is coming because slope is minus 1.1 and intercept is 14 because it's a higher value. Look to the picture as coming down. Next. Now you can ask me, sir, you have given us a lecture, but what this knowledge will help us? That is the important thing. You have a data set, pH, turbidity, TDS, EC, calcium, magnesium, sulfate. Now, somebody told that this is a data and you are giving this data. So what is the relationship between among the parameters? You will find pH has not much relation with anybody. But turbidity also has not much relation to it. But TDS has a strong relation with electrical conductance. Why? Because summation of the all cations and anions concentration is going more or less to TDS. I will explain you later very clearly. Now TDS is a total dissolved solid, that means reflecting the total in ions. So it has a good relation with the calcium and magnesium and sulfate. So this is the thing. EC also follows the thing because TDS and EC already has a very good relation, 0.999. So EC must follow good relation with calcium, magnesium and sulfate. That is happening there. Now calcium and magnesium are close. The reason is that calcium and magnesium is close. The reason is this, that they are indicating the hardness, calcium hardness and magnesium hardness. And calcium has a very good inclination to the sulfate. So calcium sulfate is available in nature abundance. That is the thing actually. So is the magnesium sulfate. So correlation coefficient indicates the result is correct because TDS must be correlated with EC. TDS has a good relation with calcium, magnesium and the anion, and calcium has a good relation with magnesium because of hardness correlation, and calcium and sulfate is there. That means total hardness is composition of the calcium hardness plus magnesium hardness. This is the way. Next. Let us interpret with the interrelation of the solids. If you take sample of 100 milliliter, in a small beaker and pass on to evaporation, you will get the settleable solids. So EMOP cones will give you this, the filter paper in the EMOP cone. You will find, you see the EMOP cones and you will put it in. After a few minutes, all the solids is deposited in the cone of the EMOP. EMOP is a man. Fortunately, I met his son who designed this EMOP cone. And sample, if you evaporate, you will get total solid. So water is evaporating in the oven, 101 degree, and you will get that it will go, all the water demolished. What is the residue is left, it is a solid. So if you measure the beaker and then evaporate the water, and after that evaporation, you again measure the beaker, difference between the two. So beaker plus weight of the beaker plus 100 milliliter water and weight of the beaker plus total solid, difference between the two, it is your already total solids. Here again, if you take the filter paper, evaporation of the filter, you get the total suspended solid. Now total solvent, it is evaporate the filter in the 101 degree, 102 degree actually in the oven, and then heat it. You measure total suspended solid, then heat it at 500 degrees centigrade in muffle furnace. You will find the fixed solids. So total solid minus fixed solid is your volatile suspended solid. Like that, you evaporate the filter and you will get the filtrate now. Now, this filtrate you are measuring. So what is suspended solid has been taken out by the filter paper. So in the beaker, what is left? It is the TDS. This TDS you measured, you evaporate it 101 degrees centigrade in the oven and measured. And then, so you get the total dissolved solid. Now you again 505 degree, you muffle furnace, you will find the FDS, the volatile dissolved solid is gone. So total volatile solids is VDS plus VSS is total volatile solid, and this is there. So this is the relation within the solid is available. And electrical conductivity is a composition of the FDS, right? So volatile dissolved solid is nothing but the organic carbons. Volatile suspended solid is also nothing but organic carbon. So TDS is correlated with EC because the ions. FDS is more correlated with the EC because FDS only tell you calcium plus magnesium plus sodium plus chloride plus sulfate plus bicarbonate and carbonate. So once you got a correlation is there and you got an equation out of it, so one measurement can measure all the things. That is the beauty of this aquatic chemistry. Next. Look, TDS and EC. And TDS 0.99 to TDS is Y and ECX X. Now, something is coming down from the x-axis, that is 0.52, and this intercept is negative. Why it is negative? But TDS contains also volatile dissolved solid, which is not reflected in the EC. So some TDS is 0 when EC values are there. EC is X, Y equal to MX, Y equal to TDS. So EC value is X. Some X value is there, and this is the when TDS was not there, or dissolved solid was not there. That means the volatile dissolved solid is not there. So TDS and total hardness has a good relation because calcium, magnesium of sulfate is that hardness. So TDS and hardness is a good relation that is there. Equation is there. So once you got the equation, you measure only conductivity. You get all the data. Only conductivity you measure, you can get all the data. And that is the beauty of this. So TDS and conductivity, if you measure, you can have a good correlation. You do not measure every time calcium, magnesium, sulfate. So when online monitoring you have to do, real-time online monitoring, you just put EC, and you get all results, provided you have a historic data to make a regression line. That is why in the environmental management, so you reduce the cost of monitoring, because if you want to online, so EC is giving you the all values, provided only checking in once in a month, you check these things. That is your calibration of the things. That is the best fit reaction and linear correlation coefficient is giving us. This equation, if you get established in any place, you can do it. And that is the same thing is happening in Ganga action plan. When I was there in CPCB, I do this exercise and find that EC is giving quite a good results of these things. Of course, it is not the data of the Ganga. It is another river. Next. Now, you see the correlation coefficient. Carbon monoxide and NO2 or NOx. Carbon dioxide and NOx has a very good relation. Why? Because source is same from the vehicle. The carbon monoxide is coming from the vehicle only, and NOx is also coming not only, predominantly. So that is why they have a things. And carbon monoxide, PM2 point have not a good relation. PM2.5 coming from different angles, from the vehicles, from the other sources, on the dust, stable burning, all the things are coming here, right? So NO and NO2, that means the nitrogen oxide and nitrogen dioxide, Dono has a good relation because they are combined is a NOx. So they have a good relation. So, but so this is the things. So matter and the your particular matter and gaseous have not much correlations. But gaseous has a correlation. Next. So this is the formula as a whole I have given to you, and you will also find out that if any exercise has been given to you, you should try. Next. I have given a small exercise to you. Please try. It's very simple. You don't have to go to Excel cell. Honestly selling, you should do with your calculator and do this exercise. Everything will be these things. I will be here. If you have anything understanding, I am sure that you understood. You are quite intelligent enough to understand the whole things. And this is very important for the environmental managers who are dealing, or environmental researchers. The interrelations of the parameters, interrelation of the stations with respect to BOD. Suppose 25 stations are there. You find some good correlation between the adjacent station. One station you can knock out from one station to another. So you can reduce the cost. That is the beauty of monitoring network design. You take 2 to 3 years of any river, you can do it these things. Same is the case of the air pollution. You can check cluster, more or less cluster of air pollution, and then find what is the correlations among the stations. You will find few stations which are very close. In Delhi, we have seen which are very close to the main road. Their correlation, they have a very good amount correlation. But those who are away from the main road, they have not the correlation. They have a different type of things are given. So some may be background, some may be reflecting industrial, some may be because of the wind speed also you get a correlation. So such type of exercise, if a environmentalist, whether is a regulator, whether is a researcher, whether is a advocacy of the game, they have to understand this. Thank you very much.